today we're going to talk about factor by grouping. So the first part says rearrange the terms so that common factors can be more easily found. So sometimes that's helpful, and a lot of times it's most helpful to write the terms in standard form, so from highest power to the lowest power for your each term. So this is degree 2 because it has x squared, and this is degree 2 because you have x to the first, y to the first. Remember, you add those together to find the degree of the term. This is degree 1 and degree 1. And if I look then at number 2, it says group the first two terms and the last two terms together. So if I group those terms, first two terms and the last two terms, then it says factor out the greatest common factor from each set of parentheses. So if I look here, the GCF, notice that there is an x and an x here, so I'm going to factor out an x. So inside my parentheses gives me 3x plus y. And then over here, I have a greatest common factor of 4 that I can take out, and I'm going to take out the negative 4. And the reason I'm taking out the negative 4 is because when I divide negative 4 out from negative 12x, I get 3x, and negative 4 divided by negative 4 is just 1, so plus y. When you are doing factor by grouping, the terms then inside the parentheses must be the same in order to do this next step. The next step is to factor out the common binomial and write the new equation. So you take the numbers in front and you're going to group those together, x minus 4, and then you take these and you're going to group them together. So 3x plus y. This is the new factored form. So let's go ahead and check our work. So if we're checking, why does that work that I can take these two first terms and put it in a binomial in front? Think about when you FOIL. So when you FOIL, you take the first term and you multiply it by both these terms. So what am I really doing? I'm taking this first term, timesing it by 3x plus y, and then you take the second term and multiply it by both of these. So minus 4 times 3x plus y. So that's the same thing that we're doing when we're foiling, and notice it's the same step that we get right here. And so that's where that comes from. It's just that you're going the opposite direction from the FOIL and writing it out. So let's go ahead and actually write that all out. So if I write it out, I get x times 3x, which is 3x squared, x times y, so plus xy. Negative 4 times 3x is minus 12x, and negative 4 times y is minus 4y. So as you can see, this checks out here. And again, if I have x times 3x plus y minus 4 times 3x plus y, and just distribute that way, you'll see you also get the same thing. So 3x squared plus xy. And then here, when you distribute, minus 12x minus 4y. So it's just another way of factoring. Looking at number 2, same thing. So this is degree 3, 2, 1, and 0 because there's no x to a power there. So x 0 powers, y is degree 0 when you have a constant. So group the terms. Then look for your GCF. So what's common between these two? X squared. So this becomes x plus 7. And then over here, we're trying to make it x plus 7, so I notice I can factor out a positive 2. So I always put the plus 2 if it's positive. And then this would become x plus 7. And again, these have to be the same in order to do the next step. So now we're grouping the terms that are in front together in its own binomial set. And then these get groups as 1. And then, of course, you'd always want to see if you can factor further. Remember, we have the difference of two squares. However, this is not a difference, it's a sum, so that does not factor any further. Looking at question 3, same thing. So if we go back here, we're going to group our terms. So this, take out the GCF. So that would be a squared. So this becomes a minus 2. Over here, the GCF would be plus 5, because that was a plus there. It's hard to tell right now. And that would become a minus 2. So these are the same. Then I can go ahead and group them together. A squared plus 5 times a minus 2. That does not factor further. So why don't you go ahead and pause the video and do 4, 5, and 6 on your own. When you're done, unpause and we'll check our work. So looking at question 4, same thing, group, then factor out the GCF. So I notice that here I factor a 3 and I have x that I can take out. So when I factor that out, it becomes y plus 7. Here, the GCF would be minus 2, and that becomes y plus 7, because negative 14 divided by negative 2 is positive 7. These are the same, so we can go ahead and group them. So 3x minus 2 times y plus 7. Looking at example 5, so for this one, when you group, you can take out x, so that becomes x plus 2. Over here, we get minus y, and that becomes x plus 2. So x minus y times x plus 2. If you ever notice that these terms are not the same when you take out the GCF, look at what you factored for the GCF first, and then maybe try to rearrange your terms. And if that doesn't work, then that means it's not factorable by factor by grouping. Over here, so let's go ahead and group our terms. So first I notice I can take out a 7, so that becomes 3 minus t. And over here I can take out a plus r, or positive r, so that becomes 3 minus t. So these are the same, so I can do my factor by grouping, 7 plus r times 3 minus t. So go ahead and see if you can do number 7 on your own. When you're finished, unpause the video and we'll look at how to factor that. So looking at question number 7, notice it's different than the ones that we were just doing. This does not have 4 terms, so that factor by grouping is for when you have 4 or more terms, which I didn't say earlier. If you do not have 4 more terms, then you use your factoring sheet that we have talked about. So that factoring sheet states that if this is 3 terms, then I'm just going to do my trinomial factoring. So with 3 terms, the first thing I look for is the greatest common factor. And the greatest common factor, these are all even. Let's try 2. So if I take out 2 from each of these and put it in front, this would be 2 times 8x to the 4th plus 10x squared minus 63. So 2 is the highest that we can take out. I still have 3 terms here and a number in front. So with the 3 terms, I'd like to do what's called Swedish Fish, and I'm going to write it all out. So Swedish fish don't really swim. If I have a number in front, I like to multiply it by this number here, and that 2 for the GCF just gets brought down. So then here, when I take the S stands for slide, so when I take that first term, multiply it by the 63 and rewrite, so that becomes x to the 4th plus 10x squared minus 504. F stands for factor, so I'm going to factor this. We know how to factor these equations. The only difference is that we have the x to the 4th there instead of x squared. So if it was x squared, you know it's x times x gives you x squared. So since we're factoring this into 2 binomial sets, that means this has to be x squared here and x squared here, because what's x squared times x squared? You add the exponents, x to the 4th. And because this is x squared, you would get a middle term of x squared. So as long as the middle term is half of this, then you know you can go ahead and factor that. So how do I find factors of 504? That's a large number, so maybe you don't know how to find the factors. You can use your calculator to help. So if I go to my y equals on my calculator and I plug in negative 504 divided by x, and then go to second graph, which is your table. So if I go to my table, 1 and negative 504, which we know we're not going to use, but I'm looking for a positive and a negative value. And if I go back to here, I know that the bigger term has to be positive to get a middle term that's positive. So our middle term is 10. So obviously these are too high. So I'm going to keep going. Still too high. So still too high. 14 plus negative 36 is not 10. 18 and negative 28. Here we go. So 18 plus negative 28 gives us 10. So that is our two numbers that we're going to use, so plus 18 and minus 28. So we slid first with first S slide. F stands for factor, the new equation. D stands for divide. Well, if I take this first term and move it to multiply here, that's not the correct equation, right? If I were to FOIL that out, that doesn't give me my original problem. So I need to divide it back out. So you divide each of these numbers by that term that you moved. So when I divide that, then R stands for reduce. 18 over 8 is going to give me 9/4. So x squared plus 9 over 4. If you didn't know that, you can go to your calculator and use it to help you. So go to your home screen, second mode, 18 divided by 8. You can hit the math fraction key. But again, make sure you know how to use fractions without your calculator because you'll need to know how to do that for upper level math. But just for now, to help you, you can do that. So 9/4. And then over here, x squared minus 28 over 8 also reduces into 7/2. This S stands for swing. So if you have numbers like this, if I were to FOIL this out, this does not equal this original equation that we have. So we want to swing these values in front. So this becomes 4x squared plus 9, and this becomes 2x squared minus 7. So this right here is my factored form, and of course I always want to make sure if I can factor it further, I look. Here I have 4x squared plus 9, so I can take the square root of this and this. So I would look to see, can I do the difference of squares? Well, this is not the difference of two squares because it has a plus sign here, so that does not factor. Here, I can't take the square root of 2. It's not a perfect square, neither is 7, so I know that doesn't factor anymore. And so that means we would be done. And you know what, I just realized these signs are messed up. So this should have been minus and this should be plus because our middle term is positive 10 and that's the lower number. So actually this would be minus and plus, sorry about that. And that means this would be minus and this would be plus, which means that that does factor further. Whoopsies. All right, let's go ahead and fix that. So this would actually factor it into, this is a difference of two squares. So we set up our two binomial sets, and this one stays as 2x squared plus 7. So square root of this would be 2x, and the square root of this is 3. So 2x plus 3 and 2x minus 3. Ooh, 3. There we go. That would be the complete factored form. And again, sorry about that. I just realized that my signs were incorrect. And of course, you could check your answer by foiling this all out. These next ones are all mixed factoring. So since these are all mixed factoring, you can go ahead and pause the video. You can take out that graphic organizer and use that to help you. And then when you're done, you can unpause the video and we'll take a look. So for this first one, how many terms do I have is what I first look for. I have 3 terms. Since I have 3 terms, I'm going to factor the trinomial. So I have to look for GCF, which there is none. Since there is none and there's a number in front, I'm going to do the Swedish Fish factoring. So Swedish Fish don't really swim. S stands for take that first number, slide, and multiply it by this number here. So x squared plus 12x plus 36. Some of you may have learned last year that you can do factor by grouping by figuring out factors that add up to that and writing the middle terms, which is fine. This is just another way of factoring. So if you have a different way of factoring it, that's okay. I'll have a video that shows the other way just to remind some of you if you're used to that way, it's fine. So looking at the next part, F stands for factor. So we want to find factors of 36 that add up to 12. Both of the signs have to be positive because it's plus plus. So x plus something and x plus something. Well, factors of 36 that add up to 12 are 6 times 6. So 6 times 6 is 36 and 6 plus 6 is 12. D stands for divide. If I move this, if I multiply this out and FOIL and combine like terms, I wouldn't get this because notice x times x is x squared, not 4x squared. So that means I need to divide the term that I moved back out. R stands for reduce the fraction. So 6 over 4 reduces into 3/2. And then S stands for swing the number in front. We can't leave our fractions like this because if we multiply it out, it does not equal this. So that 2 goes in front. So this becomes 2x plus 3 times 2x plus 3. Now if I were to FOIL this out, it would equal this up here because again, 2x times 2x would be 4x squared, and then you would get the rest of the terms as well. Another way to write this is because if I have two of these, I can rewrite this as 2x plus 3 quantity squared, and that would be my factored form. Looking at number 2, first thing I notice is there's two terms and there's a minus sign. So either it's going to be the difference of two cubes or the difference of two squares. I have to figure out which one. So first look for greatest common factor. There is none. So if I look here, I can take the square root of 81 and 400. That tells me, and this is a square here, that tells me I'm going to be using the difference of two squares. So the square root of 81a squared is 9a, and the square root of 400 we know is 20. So for the difference of squares, we set up our binomials. One's plus, one's minus. So this would be 9a plus 20 and 9a minus 20. Looking at number 3, we have 1, 2, 3 terms. There's no GCF, so we're just doing our normal factoring. So factors of 64 that add up to 16. So set up your two binomials, x, x. Since this is plus and this is minus, that means both these terms have to be minus. Factors of 64 that add up to 16 would be, of course, 8 times 8, and 8 negative plus negative 8 gives you negative 16. So this would be x minus 8 quantity squared. Looking at number 4, I notice that there are 4 terms. So that means I'm going to do factor by grouping. So remember to group the first two and the last two terms. And if that doesn't work, then rearrange your terms. And if that doesn't work, then it doesn't factor. So for this, first I take out the GCF of the first binomial set, which would give me 2 and x. So that becomes x minus 3y. Here I can factor out a positive 5, so that becomes x minus 3y. These are the same, so I can do my factor by grouping. So 2x plus 5 times x minus 3y. And then these do not factor any further, so that would be it. Looking at question number 5, so I see two terms and it's a plus sign. We don't have the sum of squares, so I know it can't be that. So here I'm going to look and I can see this is x cubed to see if I can take the cube root. So remember, if you don't know what the cube root of 216 is, you can use your calculator to help. So in your calculator, you can go to math, and number 4. The cube root of 216 gives us 6, or remember we said you can do 216 to the 1/3 power. It's the same thing as the cube root, either way. So we know this is equal to 6, and the cube root of 1 is just 1, and the cube root of this is x. So remember when you're doing your formula for this, you have a binomial times a trinomial, and we use SOAP. Same sign, so this is plus, opposite, always positive. So the cube root of this was 6x, and the cube root of this is 1. First term squared, so 6 squared x squared. First times second, ignoring the sign, so 6x times 1 is just 6x. Second term squared, so when we simplify 6x plus 1, 6 squared is 36, and x squared just stays that. Minus 6x, 1 squared is just 1. And that would be my factored form. Looking at question number 6, I see two terms. So of course, first always look for your GCF. So if I don't, then if I look here and I see a d cubed and try to take the cube root of 2, I know that is not a perfect cube, so it wouldn't work. But I do notice that there's a 2 and a 20 here, so that means I have a GCF. of 2, and also d is in both of them. So 2d. So when I take the 2d out, I end up with d squared minus 10. So now I notice I have two terms, and I can take the square root of those terms because the square root of d squared is d, and the square root of 10, oh wait, we can't take the square root of 10. It doesn't give us perfect squares, so we can take it, but notice that the square root of 10 gives us not a perfect square. So because it's not a perfect square, that means this does not factor any further. Looking at question 7, so I have two terms. I can't take the square root and get a perfect square for x cubed, so we're going to look at the cube root. If you don't know what the cube root of 64 is, or if it is a cube root, you can use your calculator. So math number 4, the cube root of 64 is 4. So the cube root of x cubed is x, so we have binomial times a trinomial. Same sign, opposite, always positive. So x, and we said the cube root of 64 is 4. So for this next one, first term squared, so the first term is x, so this becomes x squared. First times second, ignoring that sign, and second term squared, so 4 squared is 16. Here we have 4 terms, so factor by grouping. Factor out your GCF. Here, same thing, the GCF is 2y. These are the same, so that becomes x plus 2y times x plus 3. Over here, I have two terms. I can take the square root of both those terms. X squared is x, and the square root of 49 is 7. But this is a plus sign. There is no formula for the sum of two squares. So what does that mean? It means it's not factorable. So it's just prime when something doesn't factor. So since it's not factorable, this would just be our answer. It does not simplify. And that's it for our factoring.